Hi, welcome. This is a basic probability workshop and one of a series of instructional videos I plan on putting on my YouTube channel. And my name's Anthony Fiducia. Have experience as a math and stat professor at a local down here in Florida local school, and also online for many years at Purdue University Global, formerly known as Kaplan. Anyway, if you're a basic stats student, you're probably bewildered by some of the terminology that your professor is using. Some words you've never heard before, others you've heard in other contexts. And so that is one of the problems I always encountered teaching basic statistics. Well, probability is not one of those words you've never heard before. You use it all the time, and you have heard other people use probability and odds, through almost every day of your life. So what we're going to do today is to explain probability and remind you that probability is all over the place. It's everywhere. And we're going to give examples of the three kinds of probability that exist. There are three. Show you some examples of basic probability, and then end up by talking about a little bit more complex probability calculations. If you have any questions, I'll give you my email at the end of the presentation. You can also post them right on this YouTube channel if you'd like. Now, I say probability is everywhere because if you heard the weather forecast this morning, you may have heard a probability of snow or rain or precipitation is such and such a percent. That's a probability statement. If you play a Powerball or any of the other jackpots, you know that the probability or odds of you winning are extremely low. That is another probability statement. The Powerball jackpot, for example, is been in the news lately because of the high payoffs. You may also have your own probabilities, like what's the probability you're going to get this job, or what's the probability you're going to pass a particular class. You make those up yourself. That's the first type of probability we're going to talk about. And then, of course, we talked about odds. And if you're a sports person, you may want to know the odds that your team's going to win the next game or the Super Bowl or whatever. All those are probability statements. And so I say probability is everywhere, all around us. And you may or may not know that. Hopefully, after this presentation, you have more of appreciation for probability. And there are three ways, really, to find probability: classical, theoretical, relative frequency, and subjective. Those are the three kinds of probability. We're going to talk about subjective probability first in just a minute. But there's one rule, actually there's several rules. The first one I'll cover is that all probabilities must be greater than equal to 0, less than equal to 1. So you notice at this chart that I have here that the probability of, it's impossible, for example, it's impossible at one end, and it's a sure thing at another end. So, if something is impossible, it has a probability of 0. If something is sure to happen, it has a probability of 1. In the middle, it's 50-50. So, if you get a negative probability, you know something's wrong. Or if you get a probability greater than 1, you know something is is wrong because probability must be between and include 0 or 1. An impossible event, for example, what's the probability that when you flip an honest coin, you get both a head and a tail and a single flip? Well, that's impossible. You're either going to get one or the other. That has a probability of 0 of happening. A sure event or a certain event is, for example, you flip that same coin, what's the probability you're either going to get a head or a tail? I'm neglecting landing on its side and that other weird stuff. So the probability you're going to see a head or a tail is 1. One of the two has to happen. So those are some examples of probabilities of 0 and probabilities of 1. Most probabilities, of course, are in between there, in between probabilities of 0 and 1. And as I said, 50-50 is right here in the middle. Now, the first probability we're going to talk about, I said, is the easiest one. It's called subjective probability. It's the easiest one because it's a probability that requires no math at all. It's simply based on what you believe or what you have experienced. And so if you think the probability your team's going to win the World Series is 50% or 80% or 0%, that's your belief, that's your subjective probability. And it's based, again, on experience or belief. There's no math. A physician uses diagnostics and his or her training to tell you there's a 70% probability you're going to need surgery. And subjective probability is when you look out and you see clouds, and before you leave for school or work, you grab an umbrella. That's you're making a probability statement within that subjective probability. It's the easiest one, no math involved, and that's why we cover it first. And the second type of probability is called classical or theoretical probability, and this is probability calculation you actually can do in your head. Again, don't really need a pencil or paper. For example, if I ask you what's the probability when you flip a coin you get a head, well, that is a classical or theoretical probability, and all probabilities are a ratio. Here's the ratio. It's the number of favorable outcomes divided by the total number of possible outcomes. So if I ask you what's the probability of flipping a coin and getting a head, notice the way I write it there, that's equal to how many ways can you get a head if you flip a coin, honest coin? There's only one. That's if a head showed over the total number of possible outcomes, head, tail. There's 2 of them. So that's how you find the probability of getting a head or a tail. The one thing, though, about classical theoretical probability that you must remember is that you can only use that when outcomes are equally likely. What that means is that every experiment, like flipping a coin or rolling a die, has a certain number of outcomes. We call that a sample space. In other words, here's what can possibly happen if you roll a die. A die is a single part of one of a pair of dice. It's just one cube. And so when you roll that die, you're either going to get a 1 or you're going to get a 2 or a 3 or a 4 or a 5 or a 6. That is called a sample space. That's a list of all the possible outcomes for that particular experiment. And if you want to know the probability you're going to roll a 3, how many ways can you roll a 3? Well, there's only one way, and that's if a 3 shows up. And what are the total number of outcomes? 6. So the probability of rolling a 3 is 1 over 6. There's that ratio again. And I could do the same thing for the probability of rolling a 2 or a 6 or a 4 or whatever. They're all equal to 1/6. So it satisfies this criteria here that you can only use classical or theoretical probability when the outcomes are equally likely, when they all have the same probability of happening. If I ask you what's the probability of selecting a jack out of a deck of cards, remember there's 52 cards in a deck, so you have 52 choices, and there's 4 jacks, so the probability is 1 over 13 or 4 over 52. Reduce it always to the lowest common denominator. So that is those are examples of theoretical or classical probability. As I said, you can do them mentally. Very often, you don't need a pencil or paper. You just think about it. In this example right here, what's the probability? You spin a yellow. If you look at it, you see there's 3 ways you can hit yellow, 3, over the total number of possible outcomes, which are 8. So the probability of spinning that spinner and getting on yellow is 3 over 8. So remember, though, it can only be applied when outcomes are equally likely. And for example, another thing is, suppose we ask what's the probability of you rolling a die and getting an even number when you roll a die. Well, you can get even number if you hit a 2 or a 4 or a 6, right? There's 3 ways over total number of ways of 6. So 3 over 6 is 1/2. The probability of you drawing and rolling an even number is 3 over 6 or 1/2. We talked about the sample space, potential of what happens if you whenever you have an experiment. When you flip a coin, there's a sample space, head, tail. The only 2 possible things that can happen. And so we identify an event as 1 or more outcomes. And the example I just talked about, the probability of an even number when you roll a die, the event is an even number. That's when you roll a 2, 4, or 6. As I said, it's 3 over 6 or 1/2 or 0.5 or 50%. You can express probability any way you want or any way the problem asks you to. If it asks you to express it in decimal, it's 0.5. Percent, remember, you go 2 places to the right, multiply by 100, and that gives you how you go from a decimal to a percent. Now, the third type of probability calculation is the one that's used most often. It's called relative frequency. It's based on observing data, observing information. It still is that ratio we've been talking about. It's the number of ways something can happen over the total number of trials. So if we list here in this chart the blood types of 50 people, we find 22 of them are type A, B is type 5, type B is 5 people, A, B are 2 people, and positive O is 21 people. So that sums up to 50. So we can use that information to calculate probabilities. Like if you select one of those people, what's the probability that they are type A? Well, 22 of them are, so 22 over 50. So we have the numerator, number of successful trials, 22, over the total number of trials, which is 50. And so, and we can do the same thing for B, A, B, and O. Now, notice one thing here is that if you add these probabilities, and remember, when you have the same denominator, you can add the numerators. 22 and 5 is 27, and 29, you get 50 over 50. This is the second rule And that rule is that the sum of all the probabilities in a sample space, in statistics we use the Greek letter sigma that I just drew there. The sum of all the probabilities must equal 1, which that says is that if you pick a person, they either have to have type A, B, A, B, or O. Okay, so one of them must happen. So the sum of the probabilities must equal 1. Now, we're going to talk about in a minute here, what's the probability you pick someone who has both O and A blood? Well, can't happen. You either have one or the other, right? So the probability of picking someone who has both A and, notice the and A and O blood is 0. That's an impossible event. Okay? If we want to find the probability that someone has A or O, okay, well, again, the key word there is or. We'll talk about and or in a minute here. Well, A or O, well, you count up 22 plus O, 21, so that's 43 out of the 50. Or in probability means add, by the way. And again, we'll talk about that in just a minute here. So we satisfied 2 rules, by the way. One is the sum of all the probabilities must equal to 1. And notice every one of these probabilities is greater than equal to 0, less than equal to 1. That's relative frequency probability based on data. Another example, if we had a room full of 128 people, there they are, 128 people, and we classify them by gender, males and females, and their class standing, freshman, sophomore, junior, and senior, we can construct this contingency table or classification table, which just explains how many freshmen are males and how many females are freshmen, and the total number of freshmen, total number of juniors, how many of those are female, how many of those are male, and so on and so forth. Makes finding probabilities much easier, and it shows the interactions among the 128 folks that we have in that room. Also helps us in finding probabilities. So if we wanted to ask what's the probability you reached into that room and picked someone who was a sophomore, well, the rate, how many sophomores are there? 18 over, again, with the total number of possibilities is 128. So that's a probability of picking out a sophomore. The probability of picking out a female is 62 over 128. Makes it easy to find probabilities with this kind of a classification table. Notice what's the probability we can pick out someone who's both a freshman and a senior? There are none. That's an impossible event. Those are called mutually exclusive events. We can't select one person who is both a freshman and a senior. Mutually exclusive events are events that can't happen. That joint probability cannot happen. The probability of that one event and the other one happening is equal to 0. The probability that you pick out a freshman and a senior is equal to 0. Those are called mutually exclusive events. They cannot happen at the same time. Now, conditional probability is a certain type of probability that provides you with information first, and then given that information, it wants you to find a different probability. Each one of these cells in the contingency table is an and probability. And you may have seen the probability of A and B. We'll talk about Venn diagrams here in a second. Shown like that and you may have seen the probability of A or B shown like that. You can use the word and or use these symbols. They mean the same thing. So each one of these cells is an and probability. The probability that the person you picked out is a female and a junior, well, there's 24 of them out of the 128. So these are all joint probabilities, we're called. Now, suppose we ask, what's the probability the person you picked out is a senior, given that you picked out a female? So you notice this vertical line is referred to as given that, knowing that you picked out a female. So the problem is saying, hey, look, you picked out a female, okay? So knowing that you picked out a female, you're only interested in these 62 people right here, not 128, but 62. So given that you picked out a female, what's the probability that she is a senior? Well, there's 18 who are female and senior, so the probability is 18 over 62, given that you picked out a female, remember. And the probability you picked out a male, given you picked out a freshman. Well, again, you're not interested in all 128 people any longer. You're interested only in those freshmen, those 20, because you were given the information, you picked out a 20. Now, what's the probability you picked out a male? Well, 8 of them out of the 20. Remember, our sample size has shrunk now into only those who are freshmen, because that's what the problem called for. That's the information you were given. So the general formula for a joint probability, the probability of A and B, is the probability of A times the probability of B given A. As an example, the probability you picked out a freshman and a male. Well, we already know what that answer is, right? The probability you picked out a freshman and a male. Well, there's 8 of them out of the 128. We can just pick that out off of the table here. But if you need to use a formula, the formula for and is the probability, the first one, probability you picked out a freshman, times the probability you picked out a male given you picked out a freshman. This is the general formula right here for a joint probability. This is the probability of A times the probability of B given A. And that's what I did here, only I have freshman and male designations. So the probability you picked out a freshman is 20 over 128. And the probability you picked out a male given you picked out a freshman, now you're only interested in those 20, is 8 over 20. And so you do the 20 over 128 times 8 over 20. The 20s cancel out and you have 8 over 128. And remember to reduce that to the lowest fraction. So that conditional probability tells us something's already happened, and they usually use the words given that in the problem, and given that is additional information that helps you solve the problem. So those are and probabilities. We just went over this one. Each one of these cells is an and probability, but we also have an or probability, and the general expression is the probability of A or B happening is the probability of A plus the probability of B minus the probability that both happen at the same time. It's called the addition rule of probability. So the probability that we pick out someone who's a freshman or male, notice the keyword or there. Well, using the addition rule of probability is the probability, the first one, probability you picked out a freshman, which is 20 over 128, plus the probability you picked out a male, which is 66 over 128, minus the probability the person you picked out is both a freshman and a male, which is 8 over 128. Now, the reason we have to subtract this joint probability is because that probability is already included in here. And if we didn't subtract it, it would be counted twice. So the probability, or probability, or the probability you picked out, A or B, freshman or male, is 78 over 128 without reducing. So the and probability, the or probability are commonly used. They're not difficult, much easier, by the way, if you're able to use a classification table like this. If you're not, you can use the two formulas that I gave you. They can also be expressed with Venn diagrams. The intersection of two events means A and B. So this area here includes both A and B. That's the overlapping area. The union of two sets is OR, okay? That includes all of A and all of B. Now, this shows you why we have to subtract the probability of A and B when we're doing the addition formula, because if we cover this probability of A plus the probability of B, but if you don't subtract this, we would have counted it twice. So you have to subtract it like we did previously. Now, again, mutually exclusive events have no common area whatsoever, and so the probability of A and B happening, as you know, is equal to 0 for mutually exclusive events. The complementary of an event is the event that does not occur. So, and it's usually denoted by an asterisk, probably A bar like this, or the way I have it here. Either way, depending what book you look at. Both of them mean that's a complementary event. So if we know the probability of picking out a heart is 13 over 52, there's 13 hearts in a deck of 52, then the probability you do not pick out a heart must be all the rest of them, 39 over 52. The formula is that the probability of the event plus the probability of the complement to that event must equal 1. In other words, the probability of you picking out a heart plus the probability you do not pick out a heart must equal 1, because one of those two things must happen. And so just using, a little simple algebra here, the probability of picking out a heart is 1 minus the probability that you do not pick out a heart. You heard of odds. Well, you can go from probability to odds and odds to probability, both. And the odds of an event, again, they're the ratio of the probability of an event over the probability of its complement. We talked about the probability of picking out a heart is 13 over 52. The probability you do not pick out a heart is 39 over 52. So the odds are of selecting a heart are the probability you do, 13 over 52, divided by the probability you don't, 39 over 52. And if your algebra is a little rusty, remember, when we divide fractions, what we do is we take the denominator, flip it, and multiply. Okay, multiply. These are cancel, so you're left with 13 over 39, or 1 over 3. So we can say the odds are 1 to 3 that you pick out a heart. So probability to odds, here it is again. The probability of the event divided by the probability of its complement. Now you can do the same thing going backward from odds to probability. If you know the odds, add the two numbers to get the denominator. Okay, so if you see the other example, adding the two numbers, 13 and 39 gives you 52. That's the denominator. The first number is the numerator, 13 over 52. So going from one to the other is not too difficult. One other definition, and that's dependent events and independent events, which are important in probability. If I ask you what's the probability of selecting 2 jacks from a deck of cards, assuming replacement. In other words, I pick out a card from the deck, look at it, then I put it back in the deck, pick out another one. So what's the probability I pick out a jack and a jack with replacement? Well, that's the probability I pick out a jack on the first draw times the probability using the multiplication rule that I pick out a jack on the second draw, given that I already picked one on the first draw. Take them separately. The probability I picked the jack out on the first draw, well, there's 4 out of 52. The probability I picked a second jack out, given I already picked one, is still 4 over 52, because remember, this is assuming replacement. I put the first card back in. There's still 4 jack, there's still 52 cards. Multiplying the numerators and the denominators, which we're allowed to do, is 16 over 2704. That's an example of an independent event. The fact that I pulled out a jack the first time did not impact the second draw because I put it back. However, if I do the same experiment without replacement, then the probability I pick out a jack the first time is still 4 over 52. But remember, I did not replace it. So the probability of drawing a jack on the second draw, there's only 3 left. It's a probability that I picked out a jack on the second draw, given that I picked one out on the first draw. There's only 3 left, and there's only 51 cards left. So you multiply 4 times 3 is 12. 52 times 51 is 2652. That's an example of dependent events. Dependent events. So as you can see, it's important in probability to read the problem carefully, because it'll have key words. The probability that both occur means A and B. The probability that either occurs is one of the two. It's A or B. Those will always be given in the problem. Or it may say, given that. They may give you the information you already did something. That's a conditional probability. So with probability especially, you need to read the problem carefully. So I'm hoping this helped you understand probability a little better now. You can watch this video on YouTube. I have some other videos on there. I'm going to be adding more. This is one of the newer ones. If you have a topic you need help on, you can email me at my Gmail account there. You can put a comment down on YouTube if you'd like. If you have a particular topic that is a little bit more extensive, requires more work, email me and we'll talk about how I can help you. In the meantime, good luck. Talk later.